Oh my God. Electrons are parts of atoms. Okay? So, what are you going to do in this section?
I'm just going to draw it down.
Not draw it down. Write it down or draw it. Okay? When you draw it, you need to make sure to get all of this. And you might want to go through here and make sure you know what they're saying. In the center of the atom is another particle called the nucleus. So when you draw it, you might want to draw the picture, and then in parentheses, you know what parentheses are?
Yes.
In parentheses, you might write nucleus. Okay? In the center and the boss.
Okay, I know. I
neutron, positive.
Okay.
Or neutron, neutral, no charge.
I understand.
Okay? Proton, positive. And then when you go outside, electron, negative.
Okay.
And while you're drawing that, I'll just quickly read this. And then you can keep drawing while you're listening. In the center of the atom is another particle called the nucleus. Electrons occupy the rest of the space of the atom and are outside the nucleus, moving rapidly. What does rapidly mean?
Fast.
So rapidly that when we imagine them, we think of a cloud of electrons around the nucleus. The nucleus contains two types of particles. These are called protons and neutrons. Is a proton positive or negative?
Negative.
Protons are negative.
No, good.
I told you, negative and positive doesn't necessarily mean good and bad.
Okay.
Negative doesn't mean bad in this case. It just
Okay.
means negative.
Okay.
Okay? If we wish to understand the nature of electricity and atoms and electrons better, we need to know that objects can have electric charge. Just as objects can have different colors and different smells, they can also have different charges. If you have long hair, you may have noticed that your hair lifts away from your head when you brush it. This is because each hair has gathered a charge. Objects can be positively or negatively charged, or have no charge. When an object has no charge, we say that it is neutral. Electrons have negative charge. Protons have positive charge, and neutrons are neutral. What does neutral mean?
Neutral?
If protons are positive and electrons are negative, neutrons
are metal.
No, mamas. No, mamas. Metal is the conductor.
Okay.
Once you get it all together. If you have an atom, and inside that atom, you have electrons running around on the outside of the, the boundaries, and all the inside being the hippies of the atom. Okay? And they have a negative charge. Then you have protons inside the nucleus, and they have a positive charge.
Okay.
And the neutrons are next to the protons, and they are neutral. They're not positive, they're not negative. They're neutral. What do you think neutral means?
In the middle. Like, so.
They're not positive, they're not negative. They're just there. They have no charge. Do you understand?
Yes, but I don't know the word.
Neutral is the word. Not positive, not negative. No positive charge.
Like in the middle, like so-so.
Not so-so.
Like cold and hot and warm is in the middle.
No, that's what I'm trying to tell you. Don't equate that with that. Because saying warm has some amount of heat to it. And if you're equating heat with positive energy, the neutron doesn't have a charge. You know the number line. How there's 0 in the middle.
Yes.
And then you have 1, 2, 3, 4, 5, 6, blah, 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 to infinity. And then on the left side, you have -1.
And can you go up to the thing so I can take that?
-1, -2, -3. Do you remember the number line?
Yes.
Okay. If you take the number line and you try to explain the atom,
Yes.
the neutron, which is positive, would be on the right side. 1, 2, 3, 4, 5, 6, 7, blah, all the way to
Yes.
infinity. The electron would be the negative numbers, -1, -2, -3, that minus sign. The electron would be 0. Do you understand?
Yes.
No positive, no negative.
Yes. If you think I'm not listening, I am listening.
I know you're listening. I'm just making sure. Don't say hot, cold, warm.
Yes.
Because warm has some heat to it.
Yes.
0 means no.
Yes.
None. Okay?
Okay. Oh, no.
Oh, sorry. All right.
Here we go. You can do these anywhere.
The electrons are even near the nucleus. They are
Okay.
not in there, but they are near there. You see that, right?
Yes. Yes.
They're here, 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 here,
Yes.
here.
Yes.
Because-
Color that on lightly.
Okay. Explain the experiment that happened on February 25th, 1996.
So
What is it?
the voltage was so strong.
From what? The voltage of what? The voltage of peanut butter? The voltage of what?
The voltage of electricity
Mm-hmm.
was so strong that it went there, it went back, and it broke the tether, or whatever it's called.
Was the experiment successful?
Yes.
Or was it not successful? Why was it successful?
Because they still
Use
Got
your
it.
words. Take a chill pill and use your words. Why was the experiment successful?
because they still got what they wanted.
What were they after? What was the goal of the experiment?
Electricity in space.
Electricity in space. To see if they could generate electricity in space. The tether broke. Yes, it broke. But they were able, that's how they knew. Because it was so much electricity. The voltage was so strong that it broke it.
Yes.
So now they know that it's possible.
Yes.
They have to do the experiments, I don't know, 20 times. And to get it to the goal that they're after, which is to leave it up there for a long period of time. But the experiment was successful.
Yes.
Okay, write that down. Break for a few minutes.